Hello and welcome back to this course of videos on MongoDB. Now, in the last few videos in this series, we're going to look at what steps you can take after you have deployed your database to a production environment to make sure that your users are treated to the optimum experience. Now, one thing that we want to make sure is that when users commit changes to a database, that these changes are saved and never lost, for example, in the event that a server goes down. So I'm just going to show you up on the board here how the MongoDB service interacts with data files and memory when reading and writing to the database. So here's our MongoDB server. Now, when you first start up the server, your data file, so this is where all of your collections are stored. And when you first start it up, the data file maps to something called the shared view. It's called memory mapping. And what this does is then it allows MongoDB to interface with the shared view, so it can interface with your data in memory. Requests to memory are far more CPU efficient than requests directly to a data file. So this is why we want to be working and interfacing with memory instead of interfacing with the actual hard data file itself. And this is the reason why things like memcached have become so popular, which are databases in memory. So like I said, first of all, when you start up the server, the files in our data file, in our core data file, are mapped to our shared view. Now what Mongo does is every 60 seconds, it then transfers the changes that you've made to the shared view back to the core data file, which is great. However, if between these 60-second heartbeats, if you make some changes to submit some changes to your database and they're in the shared view but they haven't yet been transferred to our core data view and your server goes down, you're going to lose those changes. And obviously in a production environment, you want to avoid that happening at all costs. So that's where we bring in journaling. So the way journaling works is, again, when you first start up your MongoDB service, again, your data file is going to map to your shared view, but it's also going to map to something called a private view, which is pretty much a replication of this shared view. Now, and then going forward, every time you do any writes, so when I say writes, I mean deletes or posts or updates, it's going to write to the private view. Now, once it writes to the private view, it is then also going to immediately update our journal file in real time. Now, this journal file isn't actually storing data, it's just storing a list of all of the operations that you have requested. Now, the great thing is about keeping this journal file is at any time, if your server goes down, and so these, obviously our shared view and private view are held in memory, so they're going to be wiped, we're still going to have our journal file because this is held on disk. And what we can do is then, from our journal file, we can then push this data back to our shared view. So any changes that have been made will then be recovered. They'll be pushed to our shared view and then back on the 60-second cycle, which is configurable, by the way, they can be pushed back to our data file and everything can stay in sync. And then your users can be confident that any changes they made are not going to be lost due to a server going down. And what's more, their interaction with the database, their reads are going to be quick because they're going to be reading out of memory. So it's almost like you get the best of both worlds. You get the persistence in the data being persisted to disk or to file in real time, but you also have the speed of interacting with a database in memory. So I hope that was informative, and I look forward to seeing you in the next video.